Good morning. I'm going to go over last night's homework assignment. And in the meantime, the note sheet and homework for today will be coming around. And as soon as we get done going over this assignment, we're just going to jump right into that. It should be a pretty easy lesson today. Very simple calculation. You do need your calculators. But anyways, let's go ahead and get started. So I've went ahead and labeled most of these. I didn't label number 8. I wanted to talk about that because it's a little trickier. Um, so I want to discuss that one. And I told you guys, at least most classes yesterday, that what I would probably recommend you guys do on 9 and 10 is just go up here and use one of these that I've already done and just replace your values. But I went ahead and did them down here. So we'll get to that in just a minute. So let's talk through these just to make sure you're good with how to calculate these different answers. Don't forget, when you see percent or probability, you're going to just come up with the percent of whatever it is that's being dealt with. But when it asks you a question like C does, how many scores, you're still going to look at your percent, but then you're going to turn that into a specific number, and you're going to do that using how many people. So we'll talk about that when we get there. So first of all, what percent of scores are between 67 and 85? Again, I've already labeled these. Hopefully you did that. So 67 is here, and we go all the way over here to 85. So basically, that's 3 standard deviations. So you got two options. You could either add up all the ones that we have, or you could have remembered that 3 standard deviations from the mean is 99.7%. So that's our answer for A. Okay, let me erase the highlighting and let's look at the next one. What's the probability that scores no more than 79? Again, no more than 79 means 79 is the highest. So that's all the values from 79 and down. So there's a couple ways to do this. Again, you could calculate all the ones that are highlighted, just add them all up. What I did was I know that from here over is 50%. So I just went 50% plus 34%. So that's 84%. Okay, so very simple. Either way works just fine. You pick what's best for you. That's all I really care about. Okay, the next one, C, how many scores. See, again, it doesn't say what percent of scores, doesn't say what's the probability of that score. It says how many scores fell between one standard deviation of the mean. Now, we know that one standard deviation of the mean includes both of these two categories. 34 plus 34 is 68. 68%. But I'm not going to write 68% as my answer because it wants to know actually how many scores. Well, remember, up here in the question, there's 125 golf scores. So I've got to do 68%, so that's 0.68, times 125. So you're going to simply multiply, and that's going to give us approximately 85 scores. Okay, hopefully you got all 3 of those correct. Pretty simple. Now let's move on to number 8. Number 8 was a little tricky because it says it's normally distributed with a mean of 5 hours and a standard deviation of 15 minutes. So the reason that I thought this one was a little tricky is because the questions are asked in 2 different formats, and that threw some people off, or it has in the past. I don't know if it did you guys. See, like A is written in 4 hours and 45 minutes, where B switches it up and it's doing 4.5 and 5.25. And then C, of course, does that same thing. And that kind of threw a couple people off. So I want to talk about this. It tells me that it's normally distributed with a mean of 5 hours. Okay, so 5 hours is right smack dab in the middle, right? 5 hours. But then as we move down or as we move up, we're adding 15 minutes. So if I go here, that's 5 hours and 15 minutes. If I go again, that's 5 hours, 30 minutes. And then one more time, that's 5 hours and 45 minutes. Okay? Now, going the opposite direction, we've got 4 hours and 45 minutes. That's 15 minutes below. Then we've got 4 hours, 30 minutes, 15 minutes below that. And then finally, we have 4 hours and 15 minutes. Now, that's fine as far as hours and minutes go. But remember, there's also questions like B and C that ask, and they've put the hours in decimal form. So I want to clarify again, 5 is still 5, but 5 hours and 15 minutes, remember that's 15 minutes is a quarter of an hour. So that is actually 5.25. 5 hours and 30 minutes is 5.5 hours. So that's 5.5. And then, of course, 5 hours and 45 minutes would be 5.75. Going the opposite directions, we got 4.75. We've got 4.5. And we've got 4.25. So the questions are asked in two different ways, which maybe threw a couple of you guys off. So hopefully that will clarify it. I'm sure you guys were able to figure that out. But anyways, A, B, and C all ask about percent. So we're not going to have to calculate, which is good because it doesn't give a group of people here. So we couldn't do that. But it says what percent of the phones have a battery life of at least 4 hours and 45 minutes. So again, at least means that's the least amount. So it includes everyone from here over, which was similar to one that we had earlier. It's 50% this direction plus 34. So 50 plus 34 is 84%. Let me erase the highlighting and we'll move along to the next question. It says, what percent of the phones have a battery life between 4.5 and 5.2 hours? So 4.5, again, was 4 hours and 30 minutes. And that went all the way over to 5 hours and 15 minutes. Okay, that was your 5 hours, 5.25. So again, if you didn't make those conversions, maybe that tricked you a little bit, maybe not. But anyhow, that is 34 and 34. Remember, that's 68% plus 13.5. So that's 81.5%. And then the last one for this particular question, what percent of phones have a battery life of less than 5 hours? So remember, less than 5 hours is from the very middle over. That's 50%. But also greater than 5.5. Well, 5.5 is this 2.35 plus 0.15. That's 2.5%. So 50 plus 2.5 is 52.5%. Okay? Hopefully you guys did well with that. We're going to move on. I've already labeled these. Hopefully you have them labeled the same as I do. Again, I just put those percentages in there. You very well may have gone up here and written them, underneath this just to use the drawing that was already done. So this has one question that asked me. It says the number of hours that the employees at a grocery store worked last week is normally distributed. So we know it's going to follow this particular pattern with a mean of 24. So I put 24 in the middle and a standard deviation of 6. So I subtracted 6 this direction, added 6 this direction. If there are 60 total employees, approximately how many of them worked at least 30 hours last week? Okay, so at least 30 hours means we are doing 30 hours at the least, right? 30 hours is the smallest amount. So with that being the case, we're going from 30 and up. That 30 was the least amount. So that's 13.5 plus 2.35 plus 0.15. That's 16%, right? That's 16%. But again, that's not what the question's asking me. It's not asking me what the percent is. It's saying how many, or it says approximately how many worked at least. So 16% of what? Well, there were 60 total employees. So I'm going to do 16%, 0.16 times 60. Now this ended up being 9.6. So honestly, I wouldn't tell you that you were wrong either way. But in this particular case, I would have rounded up because it's saying approximately how many. And I would have said it's approximately 10 employees. If you'd said 9, you're not wrong either, okay? Because some people would argue, well, you can't have 0.6 people, and I get that. So you kind of have to make a decision there, which way you would round. Okay, if you're dealing with people and you know you can't have 0.6 people, if you feel like you need to say 9, that's fine. But it does say approximately how many. So with that being the case, I actually rounded up. Okay, number 10 is very similar. You got a single problem. You had a GPA that was your mean of 3.1, and your standard deviation is 0.3. So I added 0.3 this way, subtracted 0.3 that way. There are 1,800 students, and they want to know exactly or approximately how many have a GPA between 2.5 and 3.7. So again, once you have these labeled, and I know it seems like a lot to label, but once you have these labeled, it's really easy to find that range, and that range is basically 2 standard deviations. Hopefully you guys remember that 2 standard deviations, and you're welcome to add all these up, but 2 standard deviations is 95%. So 95% is the percent of how many people, but they want to know a number, how many actually had that. So we're going to do 95% of 1,800 students. So if you calculate that, I got 1,710 students. So there you have it. Okay, pretty simple assignment. Hopefully you got every one of them right. If you didn't, hopefully you see what you missed. All right, at this point, your note sheet for today should be to you. And we're going to go through, as you notice, the notes are on one side, the assignment is on the other. Today, we're talking about this thing called Z-scores. And again, it's a very simple formula that I don't think you guys are going to have any problems with whatsoever. So let's talk about this, okay? Z-scores are basically just something that allows me to understand how far or how many standard deviations a specific data value is away from the mean. So let's just say, for example, like I talked yesterday about giving you guys a test. We found the average, we found the standard deviation, and you're wanting to figure out how far your value was, how many standard deviations specifically you were away from the mean. Okay, maybe you weren't exactly on those lines that we marked, but maybe you're somewhere in between them, and you want to figure out how far away you are. So there's going to be obviously 2 possibilities. One, you're going to be above that mean. And when you're above that mean, then your Z-score is going to be positive. So that means that your data value is above the mean. So maybe the mean was 84 and you made a 93 on the test. So you're going to be above that mean, therefore your Z-score will be positive. But let's say your value was below the mean. Let's say it was still somewhat similar. Let's say it was 86 and you made a 79. Well, obviously your value is below that mean, therefore your Z-score, when you calculate, it'll be negative. When Z equals 0, that means that your data value is equal to the mean. And I think that makes sense. So here's exactly how you calculate. You need 3 pieces of information. You need X, that's your specific data value. You need mu, or we're even going to say it could be X bar. Don't forget, mu is your population mean, where X bar is your sample mean. It might be data that we're running, and you're going to find that mu or that sample mean in your calculations. When you do calculate 1var stats, you're going to look at the X bar, and that's going to be the value you put in that spot. And then, of course, standard deviation, we know where to find that when we calculate it as well. So here it is. Your Z-score simply equals X minus mu, or we could say X bar, over your standard deviation. That's it. It's a extremely simple calculation. So here's a problem. A radar detector records the speeds of a group of cars that pass by, and the mean is 46, and the standard deviation is 2.8. They want us to find the z-scores for each of these values. So remember, each of these values, they're your x. So you simply go 52 minus, what did it say my mean was? 46, divided by the standard deviation, which they told me is 2.8. So grab your calculator and type this in, and you're going to come up with a number. Now, in this particular problem, 52 is clearly above 46, so the z-score here will be positive. Hopefully you've calculated it was 2.14. So 52 was 2.14 standard deviations away from the mean. That's how you would say that, okay? Very simple calculation. Hopefully you guys agree. So this next one, it doesn't matter that 42 is smaller than your mu, your mean. It still goes in the same place, and that's what will cause your z-score to be negative. So we're going to go 42 minus 46 divided by 2.8. Okay, no rocket science here. Pretty simple problem. When you calculate this, you're obviously going to get a negative number, and that is negative 1.43. So your score here, 42, and it's not score, it's I guess it's the speed of your car, would be 1.43 standard deviations below the mean. Okay, that negative would tell me just direction. It's basically directional. All right, and then the last one, obviously, same thing. We're going to use our calculation, 47 minus 46 divided by 2.8. Very simple, and here you get 0.36. So 47 is 0.36 standard deviations above the mean. And that's really it. That's all there is to it. Now, obviously, questions could be asked a little differently because we have a formula. Like number 2, it says the mean number of total miles ran last week by each member on the track team was 4. So again, what's that? That's your mu, right? With a standard deviation of 1.2. It says if Clay's z-score, so this time we have a z-score, if his z-score was a positive 2.5, they want to figure out, well, how many miles did he actually run? So again, we're just using the same formula. We just are filling in different blanks, okay? In the top problem, we were trying to find z. We have z. So 2.5 equals the value that represents how many miles Clay ran minus our mean, which is 4, divided by our standard deviation, which is 1.2. See, same formula. You're just filling in all the different blanks except for x, which is actually how many miles Clay ran. So I'm going to solve this problem. We do so by multiplying by 1.2. So if you go calculate 2.5 times 1.2, you get 3. And that equals x minus 4. And then to solve for x, you're going to add 4. So x equals 7. So Clay ran 7 miles. Pretty simple, right? Look at number 3. A set of test papers is normally distributed with a standard deviation of 5. Okay, so my standard deviation is 5. And it tells me that Riley scored an 83. Well, that's a specific person's score. That's x, 83. And he had a z-score of negative 0.4. So this time they want me to find my mean. They want me to find mu. So here we go. Here's my equation. Z, negative 0.4 in this case, equals x, 83, minus my, minus mu, my mean, divided by my standard deviation, which was 5. There's my equation. So again, it's the same formula. It's just what am I trying to find? So here I'm going to multiply by 5. So negative 0.4 times 5 is negative 2. And that equals 83 minus mu. I'm going to subtract 83, which is going to give me negative 85. But it's going to leave me with negative mu. Well, I can't leave negative with my mean. So I'm going to divide by negative 1. So 85 is my mean. All right. And then last one, as you can tell, we solved for z. We solved for x. We solved for mu. So the last one, I bet, is the one that we haven't solved for yet, and that is standard deviation. Look at the problem. The height of a group of trees is normally distributed with a mean of 14.3. So my mu, 14.3. If the z-score for a 20-foot tall tree, so again, they're giving me x, it's 20 foot tall, and then they're saying that the z-score for it is 1.9. They want to know, hey, what's my standard deviation? All right, so let's find it. So again, my formula goes like this. Z, 1.9, equals x, 20, minus my mean, 14.3, divided by standard deviation. Okay? So again, I'm gonna just do a couple of steps here where maybe you guys would only use one. I'm going to multiply by standard deviation. So it's going to be 1.9 times standard deviation will equal 20 minus 14.3, which is what? Is that 5.7? And then we're going to now divide by the 1.9, and that will leave standard deviation alone, and that is 3. So my standard deviation is 3. So that's it. That's all there is to it. Okay. Pretty simple. I believe you guys will have no problem with these. So your assignment is on the back, and I want you obviously to do all 7. Okay. So tomorrow we'll go over this, and I know that tomorrow is a pretty normal day. Thursday obviously is not. So Thursday won't be missing class. But tomorrow we'll go over this. Make sure you understand it. If you're doing great, which I assume you will, we'll move into a new lesson. And then on Friday, we should finish up and be ready next week to test over statistics. Should be pretty simple. So hope you have a great rest of the day. Hope the storms stay away from where you're at. And we'll see you tomorrow.